So we're going to look at polynomial functions. Again, our ultimate goal is that we can learn how to some methods to solving them, but we got to know some things about them. So we're going to talk about a few things on polynomial functions in this lesson, and then it's continued in the next video too. Polynomial functions have more than one term. We're going to talk about some terminologies with polynomial functions, and then we're going to also evaluate polynomial functions. And then the next video we'll talk about their graphs. So just so that we can kind of understand how they work and what they're going to look like, which will help a lot with when we're trying to solve them. So the leading coefficient is, we have what's called the leading term, which is your highest term, highest powered term. So my leading term is my highest power, so then the leading coefficient is the number in front of that highest power. And then we're also going to look at the degree of a function and what that is, and y-intercept, and then we will talk about the evaluating part of a function. So, and the rest will be for tomorrow. So state the degree and the leading coefficient. So the degree is the highest power. So if a polynomial is in standard form, then you should have your highest term first, your next highest term, and then your next higher term. Like, they should all go from in descending order, which this one does. So this is in standard form. So if it asks you for standard form, that's what standard form is, that it's in that where the highest power is first, and then so forth. So then my leading term is this highest power term. So my leading coefficient is going to be this 7. You're going to take the sign with it. So if it was a negative, you keep that. So my leading coefficient is 7. This is my leading term. And then my degree is going to be the power on the variable. So if there was more than one variable, like a y squared, then my degree, we would add those two together. But here my degree is 3. So we're looking for us, just looking for polynomials in one variable. So that is so my y-intercept, then you will also see that on your homework, is if I plug in 0, what's the value I get? So if I plug in 0 for the variable, that will tell me what my y-intercept is, what I get when I plug that in. Remember order of operations, but so basically when I plug in 0, right, it takes out all of my variable terms. So this would be 0 minus 0 plus 0, which gives me 0. So my y-intercept is 0. So whatever I get when I plug in the 0 for the variable. So here, this one, notice, is not a polynomial in one variable. So it's not going to have standard form or anything like that. The degree actually of this term is 3, because you would add those. And then my leading coefficient, then because I have 2 that have the same power or same degree, there's not really a leading coefficient. So we are only looking at polynomials in one variable. So here, we're going to write in standard form. So I'm going to put this first. So negative 8x to the 6th. Then the next highest power is the positive 3x to the 5th. Next highest power is this 2x squared. And that is going to give me my standard form. So then this is my leading term. My degree is going to be 6. My leading coefficient is going to be negative 8, take that negative with it, and my y-intercept, if I plug in 0 for all of these terms, I would get negative 8 times 0 to the 6th plus 3 times 0 to the 5th plus 2 times 0 squared minus 4. These will all go to 0. So my y-intercept is always going to be this constant that doesn't have a variable with it. So if I don't have a constant that doesn't have a variable with it, it's going to be 0. So my y-intercept is negative 4. So in standard form already, my degree then is 3 and my leading coefficient is 3. So degree 3 leading coefficient is 3. My y-intercept would be what I get when I plug in 0. So this would go to 0, this would go to 0, and my y-intercept will be negative 3. All right. So first highest term leading coefficient would be negative 5, degree 7, and my y-intercept would be negative 45. So it's a degree of 7, leading coefficient negative 5. So the other part that we want to talk about is evaluating functions, and we did kind of talk about this with the remainder theorem, but if I'm plugging in values for a function, so here the volume of air in the lungs during a 5-second respiratory cycle can be modeled by this equation. So your lungs are going in and out and in and out. So the volume is increasing and then decreasing and then increasing and then decreasing, where V is the volume in liters and T is the time. This model is an example of a polynomial function. Find the volume of air at 1.5 seconds. So if you wanted to, you could use the remainder theorem, or I can just plug in 0.15 for my variable. 1.5, squared plus 0.173 times 1.5, and plug that in, and what I get would be my volume. So plugging that into, my function. So doing my power, so order of operation. So I get a negative 0.012485, probably don't need to do that, plus so when I plug that in, I get a total of 0.477 liters, about half a liter. So that's evaluating a function. We can also talk about if I had, like, I'm going to go to your assignment here that we're going to see on your homework. So if it asks for f of a function, we talked about this with the remainder theorem, but if I wanted to evaluate this function, that would be like plugging 7 in for this function. So f of 7 would be to take negative 3 times 7 squared minus 7 times 7. So you would have negative 3. So let me write Negative 3 times 49 minus 49. So negative 3 times 49 is negative 147 minus 49, which would give you negative 196. So this would be negative 196.